All right, today's just kind of a review of most of this stuff. I think I have my workbench running. Yep. Get rid of all this stuff. And remember, when you're using this workbench, first thing you need to do is select the table that you want to mess with. Or the database, excuse me. I want to mess with the employees database, so I have that ready to go. To create a database, you shouldn't need to do this except after this assignment. From now on, I'll be giving you databases that already have data in them. But for this assignment, you need to create it. Simple command, create database, and whatever you want to call it. Might as well type it all lowercase because whatever you type, MySQL is going to change to lowercase anyways. The SQL Workbench is going to change that to lowercase. If for some reason we shouldn't need this too often, you need a list of the databases. You use the show databases command. The reason we don't need it is once you've created a database, you can simply see them over here on this side. So there's really no reason to show them. But occasionally that comes in handy for people who are writing programs against databases. That's beyond the scope of this course. Don't forget that if you add or create a new database, it doesn't show up here right away. You need to hit the refresh button at the top. That'll get this list all updated over here. If you need to get rid of a database, you can use the drop database command, or even more likely, you can just right-click on one of these things and drop the schema. Schema is the MySQL Workbench name for a database. Either one of those will work. Unless in an assignment I'm asking you what command would you use, and I don't want you to tell me I'm going to right-click on it and drop it. Just give me the SQL command instead. Stop me if you got questions here, otherwise I'm just going to keep plowing through. To use the database, to bring it to the forefront, remember that the MySQL server has the ability to store hundreds of databases. And it's possible to actually link those all together, again, beyond the scope of this class. But we can store hundreds, dozens. You're going to have 3, 4, 5 different databases on your server. You can only use one at a time, though. You can link them together, but at any point you can only use one. The way you do that using SQL is to use the use command followed by the database name. Easier solution if you're using the workbench is simply double-click it, and now you're using that database. Notice it's bold compared to employees, which no longer is, but I want to use employees. So a couple ways to do that. And now the deeper stuff, I want to be able to create a table. That's the create table command. Again, you can capitalize the table name any way you want, but MySQL is going to make it lowercase. The workbench is. This says I want to create a new table in the currently selected database. I think I made the mistake a couple of times 2 weeks ago. I created a table but had the wrong database, the test database or something selected. So you want to make sure you've issued your use command, have the right database open before you create tables. Because if you're in the wrong one, it'll create it in the wrong database. And it won't complain. Good news is you can drop tables just like you can drop databases. So you put it in the wrong place, you can easily get rid of it. Make sure you're in the right place. And then when you create the table, you have to provide the list of fields that are in that table. The first field generally listed is the primary key. Most primary keys in database design today, and I say most, most primary keys are auto number fields that are integers. We assign a unique identifying number to every single record in this table. So the primary key is listed first. You give it a name. Usually it's something like customer ID, student ID, instructor ID, campus ID, something ID. Its data type, if it's an auto number field, is int. Designated as a primary key. These square brackets mean these things are optional. You don't have to designate fields as primary keys or auto increment or not null. When I list that first one, it's usually with a primary key and an auto increment. Primary key and not null are redundant. Anything that is a primary key cannot be null, so you don't have to list not null along with primary key. Not null is used for all these other fields down here, so that if you want one field to be required and you want the database itself to force the user to put something in there, designated as not null. Oftentimes, however, the database doesn't designate that. That's a business rule. Can't leave this blank. It's called a business rule in programming, and in programming logic intermediate, we're learning about these things. Business rules are normally encoded in a business class, not in the database, not in a form. There's this business class. There's a piece of code that's stuck in between there that most of you have not seen. That's where the business rules go, so I don't put too many business rules in my database. When I define them, I define a primary key and an auto increment. I don't use not null. My students look at me kind of sideways and going, why wouldn't you want to designate that this is required? I do, but not necessarily in the database itself. It's done in the software, so if somebody changes their mind, I can easily change the software instead of having to come in here and dink around with the database structure. After you've listed your primary key, probably an auto increment, then you list your other field types. So just as an example, let's go over here and create a table in the employees table called, let's go into test, even better. Go into the test database and create a table called TBL students. Most of my table names are plural. I've also kind of gotten away from putting prefixes on them. That prefix, I haven't found a very clear definition of why or why I wouldn't put it in there. Depends on your company. You'll have to look at whoever, if you're working for somebody else, you look at their standards and you follow them. They usually have them. You put prefixes on these things or you don't. In this case, I'm not going to create any prefixes. So then after that, if I remember right, there's a parenthesis. So I got to check the notes myself here. Yes, there's a parenthesis and then the field names. So the first field I want is probably going to be the student ID field. The field names, the MySQL Workbench will leave alone, so those I do recommend camel case so that they're easy to read. Student ID is an integer. It's going to be my primary key. In MySQL syntax, primary key is 2 words. And it's going to be auto increment, and in the MySQL syntax, auto increment is an underscore in between. How do you keep all that stuff straight? You look in the notes, you look at my examples from the recordings, look at your own examples, because most of you just finished the lab, so you've got some create table commands there, you've got some insert commands there that show you the syntax. Look at the examples. Then I might want your first name. That will be either a char or a varchar. Let's jump back to the notes here. What other data types do we have available? The other data types we have available are char. That's for fixed size text fields, like student IDs, social security numbers, phone numbers, state abbreviations. They're always the same size. They always have the same number of characters in them. That's when you use char. If it's a variable size text field, this is similar to strings in C#, you use varchar for a variable number of characters. For both of these, you not only have to designate its type, but you also designate the maximum number of characters allowed in that field. It allows the database to be more efficient. If you need large amounts of text, like more than 65 character, that's the max. You're looking at text, medium text, and long text. I think I mentioned in class that my software developer students did some research and found that most people avoid these because they're stored separately from the database, slows things down, and varchars can be up to 2,000-3,000 characters long. So you wouldn't need text, medium text, long text very often unless you're talking about huge amounts of text. There's a Datetime type that includes a date and a time, so kind of a timestamp thing. There is a date type, if you only need a date, very common. Time type. Different sizes of integers, we're just going to stick with int. If you like to type, you can type the word integer. They're interchangeable. If you need decimal places, then you use either decimal or dec, and in parentheses specify the total number of digits in your number that you expect. So if you wanted to handle a number that is up to 15,000, the number of digits in that is 5. Don't count the commas. If you then want decimal places, you have to add those to this total. This first number is the total. So if I want up to 15,000 and I want 2 decimal places, that's 5 for the 15,000 plus 2 more for the decimal places. I would define that as a 7, comma 2. So the first number is all of the digits together. How many do you want after the decimal place? How many do you want to the left of the decimal place? Add those up. That's the first digit that you put in here in place of the P. Then the second one is how many of that total do you want after the decimal place? All right, so back to my example, we want your first name. Everybody's first name's a different size, so it has to be a varchar, and I'm going to make it max 15. Why 15? Experience tells me that's usually enough for first names. It's just experience. If somebody comes in with a really long first name, more than 15 characters, it gets truncated, and somebody's going to tell me that it keeps chopping off this first name. I can go into the database and make it bigger. If I make it too big, like 200 to allow for anything, nobody's ever going to complain, but I'm honestly wasting space and database efficiency. Oops. I also need a last name, also a varchar, and we'll make that one 20. Again, from experience, a lot of hyphenated names out there. They get kind of long. Maybe I want your birth date. That should be a date time because I don't really, a date type, because I don't care what time you were born in most circumstances. Just as stupid examples, I want your shoe size. That would be no, it wouldn't be an integer, would it? Could be a 10.5. So that means it's a decimal. 10.5, that's 1, 2, 3 digits, right? 10 plus the half. So that's 3 digits, one of which is after the decimal point. Maybe I want your GPA. Also a decimal, 4.00 or 3.12. If I wanted 3-digit GPAs, a lot of people starting to do that. Go out to that third digit. Then I have the 3, and it's never higher than 4, so I need a single digit on the left of the decimal place, 3 digits after. That's a total of 4 with 3 of them after the decimal place. That's what that means. You should never have a decimal designation where the first number is less than the last two. Doesn't make any sense. I think a couple of people in class got stuck because they had the wrong definition in there and they tried to put numbers in the lab and it didn't work because there wasn't enough room. So those are dates and decimals. If I wanted to store your student, let's call it student number. That's an 8-digit character that's always 8 digits. That's an example of one that doesn't change. Another example might be your phone number. That's a char. And now here, how many characters do we make it? The answer is 10. With phone numbers, you don't store the special characters. How do you know that in the future we're not going to go to an international format and put dots between our numbers? Maybe a new campus dean comes in and said, I want parentheses around all the area codes. If we store them in the database with all those special characters, we can adjust to different formats. If we store them as just a sequence of 10 digits, then we can write code and format them however we want. So that should cover most of the data types. Maybe we'll put one in here for are you a full-time student, and you can designate that as a Boolean. We didn't see it in the notes. It's there though. And then when you're done, close parenthesis, and remember MySQL, particularly if you're listing multiple commands here in the SQL workbench, you separate your commands with semicolons. If you only have one command on the screen at any given time, you don't need the semicolon. But if you're going to type another command underneath there, like my insert command in a minute, then you want to separate them with semicolons. Questions about those examples? Okay, so here's the other type that we talked about. So int, I don't have an integer in my example. I almost used age, but It's not a real good one to store in a database. It's really calculated. How old are you? Take the current date, subtract your birth date, and figure out how old you are. So storing age takes every year we have to update all my data, or every day I have to update data. Whose birthday is it today? Change their age. Not a good plan. Once we developed a table like this, here's another example with integers and dates and decimals. We're not going to worry about foreign keys. We're not going to worry about last modified. These are notes I wrote to myself in case I need them in the future. I can show a list of tables, but more likely I'm going to want to have a description of my table. It's a great way to verify that this command worked. To execute it, you either use it with this lightning bolt, which executes all the commands in your window. Normally you'll use this lightning bolt. Shortcut key for that one on a Windows machine is Control Enter. On my Mac it's Command Enter, so if you're in the Mac lab, keep that in the back of your mind. And I get a green check mark. MySQL Workbench, that green check mark designates my command executed correctly. If you get anything else, something's wrong. If you get a yellow triangle, that's a warning, probably that truncated some of your data. You typed in a name, first name that was 15, 16, 17 characters long. It'll put it into your table, but it'll chop it off, and you'll get a warning telling you that it chopped it off. So this seems to work. I can verify that it worked by issuing the describe command, and the describe command is simply describe, and then the table name, which was students, and then issue that command, and I get my list. Student ID is an integer. When you designate integers, do not designate the size. Let the operating system, let MySQL pick the size. You just pick int. Here's my varchars, dates, decimals, chars, and notice what it did with my Boolean. It turned it into a tiny integer, which is actually less than 1 byte long. That happens automatically. Tiny int and Boolean are basically the same type. They're just a one Boolean bit flag, 0 or 1, true or false. So when you do the describes, if you're looking for Boolean there, you'll never see it because MySQL always changes it to a tiny int. But it's the same thing. Notice that all of these fields could be null, but the primary key, even though I didn't designate it, null is set to no. Primary keys do that by default. Questions on creating tables? Can't find my splitter. Where is it? Old news, good review. If you need to get rid of a table, you can. The next thing we want to learn how to do is add data to a table. Add data to a table using, more likely than not, this command, the second version of the insert command. The second version of the insert command allows us to designate the order that we're going to specify fields in. If I go back to my example and I want to insert data into this table, I'd have to list the student ID, first name, last name, birth date, shoe size, GPA, student number, phone number, and full-time flag for every single record. If I use the shortcut version, which looks like this. Now I have to provide a value for every single one of those fields. This is the short version of the command. Most database tables today have auto number fields as the first one. Why would I be entering the number for student ID? It's supposed to be assigned a number automatically. You shouldn't. Right? Please don't. There are uses of that, but they're very rare. It's usually for exporting data from one table to another. But if you're just inserting records into a table, you shouldn't be putting a number in the student ID field. You should let the database program do that for you. So that's why I'm looking at the second version of the insert command where I list the fields that I want to put values into. And you always skip the auto increment field. You never include it. You include everybody else if you wish. Insert into the table name, and then in parentheses, a list of fields. So here's the second version of that. Before I get to my values, I list the fields. And so there I had first name and last name. Capitalization isn't important. When you get into the programming components of this, it becomes important, so it may not be a bad idea to capitalize correctly. And I've already forgotten. Last name, first name, birth date. Shoe size, GPA, student number, and what's left? Phone and full-time. Oops. Those are the list of fields, and now I must provide values for every single one of those fields in that order. I can mix those up, turn them around any which way I want to. I listed them in the same order they're in the table. It's not a requirement. I listed them all. That's not a requirement. If I insert a record without a birth date, I will get a null value, which means missing, in my database. This is typically how you should be inserting records. Notice I've got every field here except my auto number field. And so then I'll insert a record for myself. Single quotes or double quotes, doesn't matter. Just whatever you put at the beginning, make sure you use the same thing at the end. I've been around too long. Everything was double quotes for a long time. Now they're flexible. I still just naturally type double quotes. You don't have to. You can just use apostrophes. You can mix and match. I think that's even a worse idea, especially here with the syntax highlighting. It makes them different. But you can do that. I mix and match unless I've got a name like O'Sullivan with an apostrophe in it. Then I put quotes around the outside so I can put an apostrophe on the inside. Dates. When you enter dates into these insert commands, there are two ways to enter the dates. Both of them are in what are known as ISO format, International Standards format, where the year comes first, then a two-digit month, and a two-digit year. If you wish, you can smush all those together into one string. If you want to make it a little more readable, put it in quotes and put dashes in between. I prefer that just because it's more readable. If you don't put quotes around it, you can't put the dashes in. I've seen some people do this. That's also legal, but to me it kind of defeats the purpose because I don't think that's terribly readable. But it's legal, even with quotes around it. My advice is use this, but I'm not going to hold you to that. As long as you format the date properly, you're good. You cannot flip those around. You cannot type the word August. You don't have that option in your insert command. The date has to be in this ISO International Standard format. When you insert numbers, don't put quotes around them. MySQL accepts them and kind of figures it out, but I'm not sending you out into the workforce putting quotes around your numbers. MySQL lets you get away with it. What MySQL doesn't let you get away with is not putting quotes around strings, not putting quotes around dates that have dashes in them. If you don't put these quotes in here, it does math. It subtracts 8 from 1958, subtracts 16 from that, gives you a number, and turns that somehow into a date. So think about the data types. You all came through programming logic beginning, and you know that you don't put quotes on numeric literals, but you do put quotes on string literals. Same thing here. The dates are the weird ones. All right, so then what? Shoe size. This is a number. type it as a number. A little hard to read up there because of the syntax highlighting here, but I've typed it with a decimal place. You can leave the decimal place out. It'll add one for you. GPA, same kind of stuff. If they're integers, don't put any decimal places in. That could cause you some trouble. Student ID number is a char. The phone number is a char. That's kind of hard to read, Volker. Yes, it is. But if we put the dashes, the parentheses, the spaces, or whatever you're putting in your phone numbers, if we put them inside that string, that's very, very limiting. The other thing to think about is when you type this SQL, generally the data that we're looking at here is not meant for human consumption. It's meant to be stored in a database. If humans are going to look at this data, what should happen is you should be using a program of some kind. It's what this visual, or it's what the programming logic students are writing. Should be using a program of some kind that displays this, formats it, stacks it nicely on the screen, makes it look nice. Most people do not use something like the MySQL Workbench to go digging around in a database to see what's going on, unless they're database administrators, maybe networkers who have a task at hand, but the results is not something that you're necessarily going to show to your supervisor or to your customers. So the fact that the data is a little hard to read in the insert command doesn't bother me much. I talked about the date. If it's all smushed together, I'll accept it because it really doesn't matter. Actually, I'm going to leave it out to demonstrate something. And the last thing we had after the phone number is whether I'm a full-time student or not, or a full-time employee or not, or whatever we're talking about here. To insert Boolean values, you either use a 1 for true or 0 for false, or what's even more easy to remember is you can put the words true or false in there. What's nice about this version of the insert command is I can now put a comma here and then insert another record right away in its own set of parentheses. Every record gets its own set of parentheses. I have no idea, so I'm making this up. And I don't have any idea here either, so we'll take it easy. We'll just do a 6. We'll give her a 4.0 GPA and give her just a slightly different ID number, phone number. Don't quote me on that. And let's say she's part-time, just as an example. Another thing I could do if I'm not sure, like with the date, is type the word null. Null is a keyword. That means I don't have this information right now. It's different. I don't know. Null is different than 0. So if it was a number, like the shoe size over here, I could put a null in there. That implies to people that I don't have this information versus a 0, which means I have it, but the value is 0, which in this case doesn't make any sense. But I could have a 0 for the GPA, meaning so far they've failed every class, versus null, which means right now they don't have a GPA. So null means missing. It's probably the easiest way to recognize it in database terminology. We can just keep stacking these. So I can put another comma in here, and another one, and another one. But for each one of these, I must provide a value or the keyword null for every single field on my field list up above here. When you're done, close it with a semicolon. Run that command. Green check mark, 2 rows inserted, good sign. If something's wrong, there'll be an error message down here, and you'll have to try to decipher it. It's not always easy to decipher. At that point, the next command that comes in very handy is the select star from students. That says give me every single record, every single field. And what we'll see when we execute this is, first of all, that the student IDs have been filled in. The nulls appear as null in the MySQL Workbench. Not all programs do that. Notice the date. Even though I didn't put the dashes in, I didn't put the quotation marks around it, MySQL recognized it as a date, inserted it into the table as a date, put dashes around it. Here's my decimal places. I said format for 3 decimal places, took my 4, added some zeros. My phone numbers looked the way I entered them, and even though I typed true and false, I got 1s and zeros in my database. That's common. You can enter one thing in the command, what gets stored behind the scenes is different. Could be different. Questions about insert? If you use that insert command, that's pretty much the only one I use anymore. I know about the other ones. You'll see some of the other ones, so maybe it's good to have reference to the notes. Somebody asked me the other day, though, what's going to happen to your website after you stop teaching? Absolutely nothing. It's going to stay there. So if you need access to these notes, if you need access to the recordings, they're going to stay on YouTube. You can get at them again later. The absolutely nothing also means that when technology moves ahead, my website will no longer be moving ahead with it. I'm not going to try to keep it up, but whatever it is when I stop teaching this semester, that'll stay up there and you can go back and reference it. Okay, so we did that. We know we just did multiple records, still give a field list, and then each set of values, each record's values, in parentheses, end with a semicolon. Just saw the select command. We can delete a row if we need to. So if we accidentally enter a record and we want to get rid of it, you can delete it. There are a number of ways to delete it. If we have time, we'll learn about that in Unit 4, the update chapter. But if you accidentally enter one twice and you want to get rid of it, you can use the delete command. The easy way to use the delete command is to say delete from whatever table, but you must specify a criteria. If you don't say this where thing here, it deletes every single record. Now the good news is MySQL Workbench has a safety catch built into it that it won't let you do that unless you authorize it to, and that takes a little bit of gyration to do. I'm not going to show you because you don't need it. What you should be doing is deleting from a table where your primary key, in this case student ID, equals some value. You pick the value. You have to know what it is. Well, over here I just made a list of all of my records. So now I could go in here and say delete from students where. You can put them all on the same line or break them. I kind of prefer you break them because it makes my job of grading a little easier instead of this big old long string and I got to scroll back and forth and around. Helps me if you break them. Where the student ID equals 2. If you use any field, if I'd said delete where last name equals door, it won't work because of the safety catch. You can only delete, because there could be 25 doors. You really want to delete them all? And so the safety catch prevents you from doing that. The only time the safety catch doesn't kick in is when you delete based on the primary key, because there can only be one. That works. So if you need to delete 20 records for right now, you're going to have to issue the delete command 20 times. But you shouldn't need that for this unit. Semicolon, enter. Now if I do my select star, she's gone. The next thing to recognize is if I put her back again. I just put her in again. Watch what happens. Notice her primary key. Why didn't it reuse 2? Somehow magically this table already knows it's used a 2. Just because you deleted it doesn't mean it gets recycled. There will never be a student with ID number 2 in this table ever again. What if you want one with a 2? The only reason I could think you would want to do that is if you accidentally deleted 2 and now you need to put her back in position 2. then you can designate that student ID 2. You can designate it, but it ought to be real rare. Remember, this is not meant for human consumption, particularly those auto number fields. Most humans, database people, maybe. Programmers, maybe, but humans should never know what their ID number is. I hate that when I go into a hardware store and they say, "What's your customer ID number?" I don't know. Here's my name, here's my phone number. Does that help? Oh yeah, your customer ID number is 187. Please remember that for future. No. If you could find it that easy, I'll come in and give you my phone number again. Most stores have gotten away from that. You have an ID number everywhere you go. It's just to uniquely identify you. The fact that there's never going to be a customer or a student number 2 again doesn't matter as long as everybody's number is unique. But it's something for you to recognize that when a row is deleted, an ID number is deleted, it's never used again. So that's delete. And finally, if you make a mistake, here's a simple version of an update command. Again, this is Unit 4, which is kind of beyond the scope of this course. If we get there, great. You'll get a little bit of experience with it. But this is an update the table name. What do you want to change? Which field? What do you want to change it to? If it's a date, this has to look like a date in an insert command. If it's a number, you have to change the number. And once again, the where clause, you'll see that again in the next unit next week, the where clause that uses the ID. If you don't use the ID, the safety catch will interrupt you again. So if you need to update, you typed one little thing wrong. Well, you know what? In this unit, if you type one little thing wrong, I could delete this whole table, click to recreate it, click to reinsert my records with the correct data, and be where I'm supposed to be. So you don't need an update command, but we can use it. Here's just an example. Again, you don't need this. I want to update my table for students. I want to set the GPA equal to 2.35, where the student ID equals 1. It almost reads like English, which is nice about SQL, but there is still syntax. You have to spell things right. You have to put them in the right order. The set has to come first, then the where. We'll learn the details of that command later, but just to show you that it works, green check mark down at the bottom of the screen, show me all my students again. My GPA is changed to 235. So it is possible. And it's something the programmers work on all the time. But it's a little beyond the scope of this unit for sure, and maybe the class if we don't get that far. I think we'll get there. So now you know how to create tables and how to get data into the tables. The next unit, we start pulling the data back out again. The value of databases is not the ability to put data in, it's the ability to get information. Remember the difference between data and information. Data is those raw facts. We talked about that somewhere along the way. Data in, we can put the data in, but what's really valuable about database programs is the ability to get the data back out again in a form of some kind of information. Give me a list of the customers whose accounts are overdue. That's information. Give me a list of people whose birthdays are this month. That's information. We can get that kind of stuff out, and that's what we're going to take a look at next week in single table queries. How do I get information back out? Then, as we saw last week when I gave you or 2 weeks ago when I gave you the overview of this stuff, many databases have dozens of tables. Here's the Premier Products table, and if I do a show tables here, it has all kinds of tables. It has orders and order lines and parts and warehouses, and I thought there were customers. Yep, there they are. It's got like 6 tables in it. Sometimes I want a customer's name and I want order information. That's 2 different tables. Using a relational database program like MySQL or Access, it is possible to take data from 2 different tables or 20 different tables and show them in one result set. One answer. That's what happens after single table queries. We'll get there. That we definitely need to do. So that's kind of the game plan for the next 2-3 weeks, is to learn how to get this data back out. But your job today, for the rest of the class, and whether you do it today or later is up to you, of course, is to go back to the website and now tackle the build assignment. So here's the SQL assignments. This lab is due today. This one is what I was due next week. The advantage of doing it while you're here is if you get stuck, I can help you. Okay. Here's an ERD. Whoa, that's a lot of tables. Yep. Here's a description. Notice the T20s and all the rest of that. One of the things to be careful of is some of these T's are, T stands for text. Some of these are fixed size, right? Like zip codes. So make sure you use the right type. Others, like addresses, are variable size. So make sure you're using the right types here. And your job is going to be to create tables for these and put some sample data in them. So here's the instructions. Enter the SQL command using MySQL Workbench. Here's how you do comments, just like in C#. Just so it's easy for me to grade, put a /* with the question number above it. Put blank lines in between so it's easy for me to read. And here are the instructions. Create a database. Create the locations table from down below. Down below it describes the location table. Your job is to issue the create table command to duplicate that. And then insert 3 sample records into it. And just keep going. You're going to create each one of those 7 tables and put 3 records into it. When you're done, in MySQL, if you stack all those commands like this, you can hit the save button and save this file someplace, wherever you want. I recommend you put it on your flash drive. And then email it to me. That's the easiest way, because then I open it up in the Workbench and I get the syntax highlighting and I get to see it. Helps me grade it. Some of you have been copying and pasting from here into Microsoft Word. Okay, that works, but then you have to remember to copy and paste. Just as easy to save this and send me the SQL file. When you save this, it will have the extension of SQL, and I'll be able to open it on my end. Questions? Okay, you're in lab. Where did my recording thing go? Wow.